Hi, this is Mr. Ozek, and today I'm going to talk to you about finding an equation of a tangent line to a curve. So in here we have what the situation we're dealing with looks like. A red line is our curve, which normally is described by some type of formula. That formula is usually given in the problem. So we have formula y equals to x cubed plus 3x squared, let's say minus 7. That would be the function that describes this curve. For each of the x numbers, you're going to get a y number, and those points are going to lie along the curve. And we're going to take a look at one of the points along the red line, and we're going to find a straight line that touches that point. The coordinates of that point are x0 and let's say this is over here, y0. These are the two numbers that are coordinates of this point, and the tangent line will be described with a formula y equals to mx plus c. We have to find that formula, and the set of steps to cover that to find that formula is as follows. First, we have to find the derivative of the curve. Second, we have to find the value for the derivative at a given point. So what this means is that that point here will have some coordinates x, x1 and y1. I'm going to call them x1 and y1 this time. y1. And we're going to have to find the value of the derivative at that point using the x number. The value of that derivative will be the slope of the tangent. And then finally, we're going to use the point coordinates for this point in order to find the formula of the tangent line. The formula that we're going to use is y minus y0 equals to mx minus x1 y minus y1. Now, the number m is the slope of the tangent. So this is what we're calculating using the derivative. Okay, so let's take a look at our curve. We have a curve y equals to 3x squared plus 4x minus 5, and we're looking for the slope of the tangent to the curve, and then finally equation of the tangent line at this point. So this is the kind of way to solve this problem. The first step is to find the derivative of the curve. Step 1, simple enough. dy dx will be equal to 6x plus 4. The reason why it's 6x plus 4 is derivative of power. Power is the index number drops in front of the function and multiplies the coefficient, and then you subtract 1 from the index number. So 2 times 3 is 6, then 2 minus 1 is x to the power of 1. And then for derivatives of linear terms, we just discard the x's. So that's what it is, 6x plus 4. Now, step 2, we have to find the value of the derivative at a given point. So our given point has coordinates of 1 and 2. This is the x coordinate, x1, and this is y1 coordinate. We're going to use that x number in the formula we got from our derivative to find the slope. So slope is 6 times 1 plus 4, which is equal to 6 plus 4, which is equal to 10. Slope is 10, and the reason why the value of the slope is 10 is because the value of the derivative at the point with coordinate x equal to 1 is 10. So again, I know the point where I'm looking for the tangent, so I'm taking a look at the x coordinate of that point. I'm going to take that x coordinate and put it into my derivative. Derivative for this function is 6x plus 4. So when I put number 1 into 6x plus 4, I'm getting 6 times 1 plus 4, which is 10. And this is the slope of the tangent. This is the slope of the tangent line. So then, using the slope of the tangent line, I can find the formula and the equation of the tangent to the curve at that point. So I'm going to use this line formula, y minus y1 equals to m x minus x1. This is a way of describing straight lines. If you have a slope, and a point through which the line goes. So I have the slope equals to 10 and I have a point through which the line goes with coordinates of 1 and 2. So let's put the values in. Y minus 2 equals to 10 inside the bracket x minus 1. So now I can simplify it a little bit. I'll get y minus 2 equal to 10x minus 10, and finally I can arrive at the formula of a line y equals to minus 10 over here, sorry, y equals to 10x plus 8, and this is the formula of a line. So let's go over each step again. Step 1, we find the derivative of the curve. Our curve is 3x squared plus 4x minus 5. Derivative of that curve is 6x plus 4. Then we find the value, so that has to be a number. We find the number that comes out from the derivative at a given point. The given point has coordinates of 1 and 2. We take the x coordinate and put it into our derivative. So then the slope will be equal to 6 times 1 plus 4, which is equal to 2. So that's the slope of the tangent at this point. And because I know slope of the tangent at that point, I can find the equation of the tangent, which is the last part of the problem, by using the line formula y minus the y coordinate of the point, that equals to slope times x minus x coordinate of the point. I put the values in and get the formula or the equation of a line, which is the tangent line at this point. Okay, let's take a look at another example. We have to find the coordinates of the point on the curve y equals to x squared plus 2x plus 1, at which the slope of the tangent to the curve is equal to 4. First step is always the same. I'm always looking for the derivative of the curve. So let's take a look at step 1. dy dx equals to 2x plus 2. Derivative of x squared is 2x, and derivative of 2x squared is plus 2. Now step 2, here's the thing. I know what the slope is in here. I know that slope equals to 4. But I also know that slope is the value of the derivative at a given point. So the slope is the value of the derivative at this point over here. This point has some coordinates, x1 and y1. And I'm trying to find for what x the value of the slope is equal to 4. So I know that the derivative tells me what the slope is at a given point. So let's say 2x plus 2 equals to 4. For some x number, the value of the slope will be equal to 4. Now I need to solve an equation. So 2x equals to 2. Move number 2 onto this side with an opposite sign. So then divide both sides by 2. And I'm ending up with x equals to 1. So value of the slope of the line of the tangent line is equal to 4 for x equal to 1. Okay, so this number x will be equal to 1. And for every number x, this curve gives me a y number. So this for x number equal to 1, I will have some number coming out from this curve. So 3, find y coordinate. So to find y coordinate, all I need to do is just put x equal to 1 into my curve equation, and that will be equal to y equal to 1 squared plus 2 times 1 and plus 1. So y equals to 4. So at x equal to 1, the value of the curve, y of the curve, equals to 4. So the coordinates of the point where the tangent to the curve is equal to 4 are 1 and 4. Okay. So finally, the third type of problem is that we have a coordinates of the point on the curve. We have to find the coordinates of the point on the curve given with this formula where the tangent to the curve is parallel to y equals to 3x plus 4. So in an equation y equals to 3x plus 4, the number beside the x is slope. And parallel lines have equal slopes. So if parallel lines have equal slopes, I know that slope of tangent will be equal to the same number as the slope of this line, which will be equal to 3. So now, step 1, we have to find the derivative, and that will be dy dx equals to 2x minus 3. Step 2, I know that 2x minus 3 equals to 3. So that 2x will be equal to, move minus 3 onto this side, positive sign, will be equal to 6. That gives me x equals to 3. So what this tells me is that point with x coordinate equal to 3 will have a tangent with slope equal to 3 as well. If that's the case, I can find the y coordinate of that point by putting number 3 into the original curve equation. So if I do that, I'm going to get that y equals to 9 minus 9 plus 7, which will be equal to 7. So the coordinates of this point P, is 3 and 7. So these are the 3 types of problem that we might have to deal with. The first one, where we have to find the equation of the tangent. So to find the equation of the tangent, we find the derivative first, we calculate the value of the slope, and then finally we use the formula for a line to find the equation of the tangent. The second type of a slope, we might have to find the coordinates of a point where the slope of the tangent is given. So again, we have to start with finding the derivative. We know the value of the slope. The value of the slope will be equal to 4 in this case. And from knowing the value of the slope, we can try and find for what number x the value of the slope is equal to what's given. And finally, if we find the x number, by substituting that x number into our curve, we can find the value of the y number. And then we have an ordered pair which tells us the coordinates of the point on that curve. And finally, the third type of problem you might have to deal with is if you're given a curve and you're given a line that's parallel to the tangent. So then from the parallel line you identify the slope, because slopes of parallel lines are always equal. The parallel lines always have equal slopes. So if you identify what is the value of the slope, the value of the slope is the same as the value of the derivative at that given point. So by finding the derivative and setting up an equation, you can find the coordinate, the x coordinate of the point where the tangent is parallel to a given line. So if you find that x coordinate, by substituting the x coordinate into the equation of your curve, you can find the y coordinate for that point to get the coordinates of the point. So the steps are always, the first step is always finding the derivative, and then depending on the type of problem, you might either have to find the line or solve a simple equation to find the point coordinates. So hopefully this was useful. If you have any questions, make sure to leave them in the comments, and I'll leave it here. So thanks for watching and thank you for your time. This is Mr. Olczek out.